So let's begin with the first part. Innovation and biotechnology behind Rovabio Advance. So I will first ask Aurélie the question, what were the main goals when you started working on this new project? And what parameters or factors did you investigate at the beginning of the project of Rovabio Advance?
Okay, so in feed ingredients, non-starch polysaccharides represent the important anti-nutrient compounds as they limit the accessibility of endogenous enzymes to their substrate. So consequently, it is largely accepted that non-starch polysaccharides reduce feed digestibility. So the aim of developing new enzyme solution is to improve feed efficiency and reduce the feed costs by increasing the accessibility to dietary compounds such as protein, starch, and lipids. So based on the scientific data, knowing substrate and the physiological limitation of the digestive tract of the animals, it is reasonable to expect a potential of improvement of the indigestible fraction up to 35% by using enzymes. That would be translated into an improvement of 7% of the global feed digestibility. The way we evaluate the efficacy of enzyme is first by measuring its effect on the nutrient digestibility, and then based on this digestibility measurement, nutritional matrix and the reduction cost can be estimated and validated with growth performance trials.
Yes, so you mentioned cost benefits, and I will present the benefits of Rovabio Advance for our customers, because during the scientific and technical development of Rovabio Advance, we validated that the product will fit the requirements of the customers. And those requirements are three. Of course, Rovabio Advance should bring profitability. And we wanted to make sure that Rovabio Advance added to the feed will bring at least $10 saving per ton of feed treated. Second requirement is the reliability. Our customers need a product that can adapt different diets and different changes in the diet. So we wanted to make sure that our product is reliable. And the third one is the sustainability. We want to secure the production of our customers, and they need a product that will allow to reduce the impact on the environment. And Rovabio Advance, by reducing the excretion and by reducing the amount of feed that is needed to make animal proteins, it is good in that sense. So these requirements are really important, and they were validating during the scientific and technical development of the product. Now, maybe to explain a bit more the genesis of the project, the Rovabio Advance project, I propose that we look backgrounds and focus on the strain producing the Rovabio range. Olivier, could you tell us a bit more about this strain? What were the interests of exploring its genome?
Yeah, so the Rovabio products are obtained by fermentation of the filamentous fungus Thalaromyces versatilis. This is a natural microorganisms found on decaying biomass. And so for this, it is equipped with a full set of enzymes to degrade all kinds of plant polysaccharides in order to maximize its chances to survive in nature. The table shows the diversity of enzymes inside different categories of enzymes involved in non-starch polysaccharides degradation. Here, mainly cellulose and hemicellulose, and compared to different industrial microorganisms. What we can do is having a look at the diversity of the product thanks to bidimensional electrophoresis. You can see the spots, but this is not representing the full diversity of the product. And there is some potential that is present on the genome, not seen here. So thanks to genome sequencing and gene annotation of our unique strains, we were able to find complementary genes coding for complementary enzymes that are already present in the product.
Okay, so you talked about the potential, but how did you optimize the mix of enzyme present in Rovabio Advance?
So one important point at the beginning was to preserve the enzyme diversity, which is key for the product versatility. And considering this, it wasn't a solution to use the same way as our competitors to produce enzymes consisting in overexpressing only one enzyme by one microorganism. So we had to think differently to do this. And this has been done thanks to all the scientific research done for the past 10 years, as well as with external scientific expert and in-house work. For this purpose, we investigated ways to improve gene regulations. And let's compare this to the traffic regulation, where the cars would be the enzymes, and the traffic lights, where they would be the transcriptional factors. And we found a way, in fact, to set the green lights even longer for the genes involved in arabinoxylan degradation and for more genes involved in this pathway. So technically, we obtained this by enriching the amount of one specific transcription factor in the cell, so XLNR. And the effect is that when XLNR is in a higher amount, it will induce more genes involved in arabinoxylan degradation while keeping the other unmodified.
Thank you,
and
Olivier.
By the end, so by the end, the most important is that the Rovabio Advance is richer in xylanase and arabinofuranose activity.
Okay, and that allows to attack better the indigestible fraction of feed.
Yeah, and we'll see the substrate just after.